In this episode, we are going to make two parts of networking feel much simpler by putting them into plain language and connecting them to the kinds of problems users actually report. New learners often see a list of internet access types on one side and a list of network types on the other, and it can feel like two separate piles of terms that have to be memorized. A better way to learn them is to ask two easy questions. First, what size or purpose is this network meant for? Second, what kind of connection is carrying data in or out of it? Once you ask those questions, the names begin to make sense because they describe either the shape of the network or the path it uses to reach services beyond itself. That is why this topic matters on the CompTIA A+ exam and in beginner support work, because users do not say, "I have a wide area network problem" or "my fiber connection is unstable." They say the office network is slow, my earbuds keep cutting out, or my home internet is fine for browsing but bad for video calls. And your job is to connect that complaint to the right network type or access type underneath it. Before we continue, a quick note. This audio course is part of our companion study series. The first book is a detailed study guide that explains the exam and helps you prepare for it with confidence. The second is a Kindle-only ebook with 1,000 flashcards you can use on your mobile device or Kindle for quick review. You can find both at Cyber.Me in the Bare Metal Study Guide series. The first big idea is that a network type and an internet access type are not the same thing, even though beginners often hear them together. A network type describes the kind of environment or scope you are dealing with, such as a small local network in one room, a wireless version of that same local setup, a network that stretches across large distances, or a network built mainly for storage traffic. An internet access type describes how a home or office reaches outside services, such as cable, DSL, fiber, fixed wireless, satellite, or cellular service. That difference is useful because a user can have one network type inside the building and a completely different internet access type connecting that building to the outside world. For example, a small office might have a LAN and a WLAN inside, while using fiber or cable to reach the internet. If you keep those two ideas separate in your mind, study gets easier because you stop trying to force one term to explain everything. One group of terms explains the layout or purpose of the network itself, and the other group explains how that network reaches beyond its own local space. A local area network, LAN, is one of the easiest network types to understand because it describes a network that covers a small local space, such as a home, a classroom, a store, or an office suite. Devices on ALA North are close enough to communicate as part of the same local environment, which usually means they can share printers, file access, and other nearby resources without needing to travel across a long-distance provider network first. ALAN is best suited for day-to-day local communication where speed is usually good and delay is usually low, especially when wired connections are involved. That is why office desktops, shared printers, and nearby servers often feel responsive when the local network is healthy. For support work, the big expectation is that a LAN should usually be faster and more stable than the internet path beyond it, because the traffic is staying inside the building or local site. If users can still reach the local printer or file share, but cannot open outside websites, that is a clue that the LAN may still be fine while the internet access path has the problem. A wireless local area network, WLAN, is closely related to ALAN, but it uses wireless communication for at least some of the local network access instead of relying only on cables. Phones, tablets, laptops, and many other mobile devices often depend on the WLAN so they can move around while still reaching local resources and the internet. A WLAN is best suited for convenience, mobility, and flexible access in homes and offices where users do not want every device tied to a cable. The trade-off is that wireless performance can change with distance, walls, interference, and crowding in ways that a wired LAN often does not. That means support expectations should stay realistic. A strong WLAN can work very well, but it is also more sensitive to room layout, access point placement, and nearby signal conditions. If a user says the network is great at one desk but weak in the back room, that sounds much more like a WLAN coverage or interference issue than a failure of the whole local network design. A wide area network, WAN, is a network that spans a much larger distance than a simple local setup. In plain language, a WLAN connects networks or users across cities, regions, or even countries instead of keeping communication inside one small building or site. The Internet itself is the most familiar example of a WLAN, but businesses can also use wide area links to connect branch offices, remote workers, and shared business services across large distances. A WLAN is best suited for communication between places that are far apart, not for pretending that those places are as close and fast as one room full of wired devices. That is why beginners need to keep their expectations realistic. Traffic moving across a WLAN often deals with more delay, more provider dependence, and more points where trouble can happen than traffic staying inside a local office. If a remote worker can use local devices fine at home, but struggles only when reaching company systems far away, the problem may live in the WLAN path rather than in the home device itself. A personal area network, PAN, is much smaller and more personal than ALAN or WLAN. A PAN usually connects devices that belong to one person and stay very close together, such as a phone with earbuds, a smartwatch, a fitness tracker, or a wireless keyboard. Bluetooth is one of the most common technologies people associate with this kind of network because it supports short-range communication between nearby personal devices. A PAN is best suited for convenience and low-power personal connections, not for wide coverage, high speed over long distance, or heavy office file movement. That shapes support expectations in a very important way. If earbuds cut out when the phone is in another room, or a smartwatch loses connection when the user moves too far away, that does not automatically mean the device is broken. It often means the user is expecting PAN technology to behave more like a full WLAN or a wired network, even though it was designed for short-range personal use instead. A storage area network, SAN, is less visible to everyday users, but it is still important to understand at a basic level because it explains how some environments handle storage in a more specialized way. ASAN is a network built mainly to connect servers and storage systems so large amounts of data can be stored, accessed, and managed efficiently. It is best suited for environments where storage performance, centralized data handling, and reliability matter a great deal, such as larger business or data center settings. Beginners do not need to think of ASAN as a normal office network where users browse the web or pair headphones. It has a different job. It exists to move storage traffic in a focused and organized way. That shapes support expectations because a problem in ASAN may show up as slow access to stored business data, backup trouble, or issues reaching centralized storage resources, rather than as a simple internet outage or weak Wi-Fi complaint. Once the network types are clear, internet access types become easier because you are now asking a different question. You are no longer asking what kind of network this is inside the environment. You are asking how this home or office reaches outside services beyond its own local area. That outside path matters because the local network can be healthy and still feel useless to the user if the internet access type is unstable, slow, or poorly matched to the workload. A household that streams video, takes remote classes, and joins video meetings has different needs from a small office that mainly checks email and uses web applications. This is where support expectations start to matter a lot. Some access types offer very high speed and low delay, some vary by location and provider quality, and some work acceptably for light tasks while struggling with heavy real-time traffic. Learning them becomes easier when you compare them by how they usually behave in the real world instead of trying to memorize names without context. Cable internet is a very common broadband access type in homes and many small offices, and beginners usually understand it best when they think of it as a shared high-speed service delivered through cable infrastructure already used in many neighborhoods. Cable is often best suited for general home and office use because it can provide strong download performance and supports common activities such as browsing, streaming, cloud tools, and video meetings reasonably well when the service is healthy. At the same time, support expectations should include the idea that local neighborhood demand can affect the experience because many users may share the same general provider infrastructure in the area. That means performance can sometimes dip at busy times even when everything inside the home or office is working correctly. A technician should keep that in mind when users say the internet becomes worse in the evenings but looks normal earlier in the day. Cable is often fast and practical, but like every access type, it has conditions that shape what the user actually feels. Digital subscriber line, DSL, is another broadband access type, and it usually rides over phone line infrastructure rather than cable infrastructure. DSL is best suited for locations where it is available and where the user's needs are moderate rather than extremely demanding. It can support basic browsing, email, and many normal online tasks, but it may offer lower speeds than cable or fiber, especially depending on distance from provider equipment and the exact service level available in that area. That means support expectations should stay grounded. A small home setup using DSL may work perfectly well for light office tasks and web use, while struggling more when several people are streaming, gaming, and joining high-quality video calls at the same time. For beginners, the important lesson is that DSL is not automatically bad. It is simply a connection type with more modest performance in many situations, and that shapes how a user's complaints should be interpreted when speed or real-time quality becomes the main concern. Fiber internet is often the access type beginners hear praised most strongly, and there is a practical reason for that. Fiber is best suited for very high-speed service, strong overall performance, and workloads that benefit from lots of bandwidth and generally low delay. Homes and small offices using fiber often get a smoother experience for streaming, cloud tools, large downloads, video meetings, and other demanding tasks, especially when several devices are active at the same time. That does not mean fiber makes every problem disappear, because a weak WLAN, a bad cable, or a misconfigured device can still create a poor experience inside the building. But it does mean that the outside access path is less likely to be the main limit when the service is provisioned and functioning correctly. For support expectations, fiber usually supports heavier use better than older or slower access types, which is why users who switch to fiber often notice an improvement in demanding tasks, not just in raw speed tests. Satellite internet is best suited for locations where wired broadband options are limited or unavailable, especially in remote or rural areas. It gives users a way to reach the internet when cable, fiber, or good DSL service may not exist, which makes it valuable even though it comes with trade-offs. One of the biggest expectations beginners need to remember is that satellite service often involves more delay than land-based broadband. That delay can make real-time tasks feel less smooth, even if ordinary browsing and some streaming still work. Weather and service conditions can also affect the experience in ways users do not always expect. Fixed wireless is another option that can be useful in places where wired service is weak or missing. It often depends on a radio link between the user location and provider equipment, so line of sight, distance, and local conditions can matter a lot. Both satellite and fixed wireless can solve important access problems, but technicians should expect them to behave differently from fiber or cable and explain those limits in plain terms. Cellular internet access is another very common option now, especially through phones, hotspots, and backup connections for home or office use. Cellular service is best suited for mobility, temporary access, travel, backup connectivity, and situations where a user needs internet in places without a normal wired connection. It can work very well in some locations, but the experience depends heavily on signal quality, provider coverage, local congestion, and the user's plan. That means support expectations should stay flexible. A hotspot may be excellent for checking email, cloud documents, and light browsing, while struggling during peak congestion or when several devices try to stream or hold long video calls at once. This is why technicians should not assume cellular access will always behave like home fiber or cable. It is powerful because it travels with the user, but mobility and convenience do not erase the limits created by coverage and shared radio conditions. The easiest way to compare all of these terms without memorization fatigue is to sort them by purpose instead of trying to force yourself to remember a giant mixed list. LAN and WLAN are about local communication inside a home or office, with WLAN adding mobility and more sensitivity to signal conditions. WAN is about communication over larger distances. PAN is about very short-range personal device connections. SAN is about specialized storage traffic. Then on the internet access side, Cable and fiber are often strong everyday broadband options. DSL may be more modest, but still useful. Satellite and fixed wireless help where wired service is limited, and cellular gives mobility and flexibility with location-based performance. When you group the ideas that way, they stop feeling like trivia and start feeling like common-sense categories. That is exactly what beginners need, because support work is not about reciting definitions. It is about hearing a complaint and knowing whether it sounds like a local network issue, a personal device range issue, a long-distance connection issue, or a limitation of the internet access type itself. The main takeaway from this lesson is that network types tell you what kind of environment or purpose you are dealing with, while internet access types tell you how that environment reaches outside services. ALAN and WLAN shape local communication. AWAN connects across distance. APAN handles short-range personal devices, and ASAN supports specialized storage traffic. Cable, DSL, fiber, satellite, fixed wireless, and cellular each provide outside access in different ways, and each one sets different expectations for speed, delay, stability, and coverage. Once you understand those basic differences, study gets easier because you no longer need to memorize every term as an isolated fact. You can place each one in a simple mental map and use that map to understand what users are likely to experience. What kinds of problems make sense for that setup, and what kind of support answer is most likely to move the problem in the right direction.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.